Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Well, happy to meet you again. Today we are going to talk about the gas laws. The gas laws. Now, at the end of this lesson, you will know what gas laws are. The fundamental laws that explains the gas laws. How to solve problems related to the behavior of gases. Now, the gas laws. The gas laws was first of all experimented by Robert Boyle in 1662. Before scientists and physicists, chemists came together and saw that temperature and pressure were numerically related. They saw that when an increase comes in pressure, there will be an increase in temperature. In essence, the pressure is proportional to the temperature, and the temperature is proportional to the pressure. We talked about that when we talked about the kinetic theory of matter. So the gas laws talks about how gas moves, how gases do their movement based on when pressure increases and when temperature increases. Okay, how they characterize their attitude and character. This is what the gas laws is basically telling us about. Now, what are gas laws? What are gas laws? Gas laws are a set of laws that describe the relationship between thermodynamics, temperature, pressure, and volume of gases. Thermodynamics, temperature, pressure, and volume of gases. Remember, when the temperature increases, when the pressure increases, the temperature will increase and the volume will increase. Okay? In some cases, the volume decreases. In some cases, the volume increases. So these laws that brings the relationship, that describe the relationship between thermodynamic, temperature, pressure, and volume of gases is called the gas laws. It's called the gas laws. The temperature, we will know how the temperature, pressure, and volume of gases talk about the gas laws. You know what the thermodynamic is. Okay? You know what thermodynamic is, work. Now, in this case, the thermodynamics is talking about work. So the work, temperature, pressure, volume, and gases. That is the gas laws, what the gas laws will tell us as we are going further. Now, a gas laws, when they say gas laws, things came together and formed these laws. Okay? But a gas law is a simple mathematical formula that allows you to model or predict the behavior of gases. That allows you to model or predict the behavior of gases. That mathematical formula you use in explaining the gas laws is a gas law. That mathematical formula you use in explaining how temperature, pressure, volume, and thermodynamic relate with gases is the gas laws. As we are going further, you will know more as we are going. Now, the fundamental laws of the gas laws. These are the laws that make up the gas laws. These are the laws that talk about pressure, temperature, thermodynamics, okay, and the volume of gases, how they behave and how they relate. Okay, these are the laws. We'll know. We'll talk about them one after the other. The first one says Boyle's Law, Charles' Law, Avogadro's Law, LUSSAC'S Law of combining volumes, and the Dalton's Law of partial pressure. Now, let's explain the gas laws using these laws, using these fundamental laws. Okay? Now, the Boyle's Law tells us that the volume of a gas increases as the pressure decreases. The volume of a gas increases as the pressure decreases. In essence, as you reduce the pressure on a gas, it says the volume will increase. That's what it told us. As you reduce the pressure on a gas, it said the volume will increase. In essence, if a gas is placed under heat or pressure, as you reduce the pressure, the gas will definitely be increasing. Why? Because the vapor that will coming out will definitely be increasing. That's what they said. So Charles' Law tells us the volume of a gas increases as the temperature increases. The volume increases as the temperature increases. The first one tells us that the volume increases as the pressure decreases. This one tells us that the volume of the gas increases as the temperature increases. Now, when you increase the temperature of a gas, okay, the molecules increase. That's what we're talking about. So when the molecules increase, the volume will definitely be increased. If you give birth to one child, you have one lineage. If you give birth to 3 children, you have 3 lineage. You have 3 lineage already. Now, the space they're going to occupy in your house will be more than when you had one child. That's what he's saying. So if the temperature increases, if the kinetic energy increases, that's the temperature, the molecules will increase. And once they increase, you know that when the temperature increases, they move randomly. So as they are moving, they are occupying more volume than before. Now, Avogadro's law tells us that the volume of gas increases as the amount of the gas increases. Yes. As you're putting more gas, the volume is increasing. All of them is talking about volume, how the volume will increase and decrease, as you're seeing. So as you're putting more gas, that is how the volume of the gas will increase. As you're adding more water into a bucket, that is how the volume of the water will be increasing. Now the LUSSAC'S law tells us that gases combine in simple ratio. Gases combine in simple ratio. Simple. If I put hydrogen and oxygen, it gives me water. There's a simple ratio there, 2:1. 2:1. And the product will give me only one product. In essence, the 2 ratios has combined and give me one simple ratio. So the 2:1, hydrogen has 2, oxygen has 1. So the 2:1 has given me 1 water molecule, 1 molecule of water. In essence, both of them combine a simple ratio and gave me 1 ratio. Okay, so they combine to give me 1 ratio. Now the Dalton's law tells us about the pressure of gases in a closed container. How the pressure of gas is high when you close the container, because they're looking for a way to escape. Oh no, as we're going further. Now the first one is the Boyle's law. The Boyle's law, okay, 1662, that is when the Boyle's law came. Okay, he had to make a relationship concerning the compressibility and the expansion of gases. How will a gas expand and how will a gas compress? That's why I said the pressure, as the pressure is decreasing, the volume is increasing. In essence, as they have been expanding, their volume is increasing. Now, this same experimental evidence came in 1772 when Moriarty still came and made the same thing. He followed the lineage of Boyle and saw that when he made his experiment, he saw that what Robert Boyle was saying was correct. Because he reduced the pressure of hydrogen gas. When the pressure of hydrogen gas was reduced, he saw that the particles of the gases move randomly. And as they're moving randomly, they are occupying more volume in the confinement they were confined in. And he came to support this law. That is why the Boyle's law is still called the Moriarty's law. Or you can call it the Boyle Moriarty Law. The Boyle's law is still called the Moriarty's law, or you can call it the Boyle Moriarty law, under several conditions. In essence, when the volume is decreasing, when the volume is increasing, the pressure is what? Decreasing. So in essence, they are not equal. They are not equal to each other. Now let's take the Boyle's law. Like I said the Boyle's law, is still called the Moriarty's law. Now, if you check on your screen, you will see the pressure reading. As the pressure is reducing, the volume is increasing. As the pressure is increasing, the volume is reducing under heat. As you can see, there's a heat there. And that is a graph explanation of the Boyle's law. There's a graph there. The Boyle's law graph is on the right, and the illustration of Boyle's law is showing you that. It states, the volume of a given amount of gas at constant temperature varies inversely to its pressure. In essence, if the temperature is constant, it's the same, okay, the volume and the pressure will not be equal. When the temperature is the same, the volume and the pressure will not be equal. In essence, if the temperature is the same, that means the pressure will be the same as the temperature, because it is the pressure that brings the temperature. So at the temperature, as the pressure is acting on the volume of the gas, the volume of the gas will be what? Increasing. The volume of the gas will be what? Increasing. Why? Because the gas is not facing much pressure anymore. It's not facing much problem anymore. So in essence, instead of him to reduce via escaping anyhow, it's going to be increasing because there is no serious problem. It's like water. Take for example water. If you increase the temperature of water, you see that the water will reduce. Why? Because the evaporation rate will be high. The evaporation rate will be very high. But if the water is reduced, if the pressure is reduced, you will see that the water will maintain its volume for a very long time. So the molecular expression says P1 V1 equals to P2 V2. Next, then the P1 becomes the first pressure, the V1 is the second pressure, the V1 is the first volume, P2 is the second pressure, and the V2 is the second volume. Now, this particular formula can still be written. Particular formula can still be written as P V equals to K, where K is the constant. Okay, K is the constant. That means K is the temperature constant. This K becomes the temperature constant. K becomes the temperature constant. And I can still write it as, if PV is equals to K, okay, then P will be equals to K over V. You can still write it like this. You can still write it like this. Or you can still write P equals to P inversely proportional to 1 over V. Any which way you write the formula, it is correct. Because they said it's inversely proportional. That means it is not equal to the pressure. It's not equal to the pressure. This PV is the constant. So if PV is equals to K, that means to say P will be equals to K over what? V. So any which way you write it, you are correct. Any which way you write it, you are correct. Now, let's take some question on Boyle's law. Let's take a question on Boyle's law. Now the question says, if 275 centimeter cube of a gas has a pressure of 670 millimeter mercury, find the volume if the pressure is reduced to 650 millimeter mercury. Now, the solution. We said the formula for Boyle's law is P1 V1 equals to P2 V2. In essence, whatever you have here will be equal to what you have here. Whatever you have here will be equal to what you have here. So, now, in every equation, the first pressure, the first volume becomes the V1. The second volume becomes the V2. The first pressure becomes the P1, and the second pressure becomes the P2. Now, we say P1 V1 equals to P2 V2. Now, if you check, if 275 centimeter cube talks about volume, okay, of gas, has the pressure of the centimeter talks about volume. So in essence, has a pressure of this. That means our first pressure is 670. In essence, P1 is equal to 670 millimeter mercury. While our V1, like I said, is 275 centimeter cube. Because the centimeter cube talks about volume. That's our first volume. So the V1 will be equal to 275 centimeter cube. Now, find the volume if the pressure is reduced to 650 millimeter mercury. You're looking for the volume. In essence, the volume you're looking for is the second volume. There's no second volume there. The volume you're looking for is the second volume. So your second volume. So they say if the pressure is reduced, that means to say the second pressure is 650 millimeter mercury. So the P2 will be 650 millimeter mercury. While the V2 is unknown. That's what you're looking for. The V2 is unknown. That's what you're looking for. So now, let us make a calculation. If they say P1 V1 equals to P2 V2, it means that P1 times V1 equals to P2 times V2. That's the illustration. So in essence, it is going to be 670 times 275 equal to 650 times V2. Because our P1 is 670, our V1 is 275, our P2 is 650, our V2 is unknown. Following the law, following the rule and the formula for Boyle's law. Now, our V2 will be what? You've checked here. Presently now. You've checked here. Now, this is 670 times 275. Equal to 650 times V2. Now, I want to look for V2. I am going to ask the person that is with V2. If I see you going out with my younger brother, okay, and I'm looking for my younger brother, maybe night has come, I did not see him, I'm looking for him. I'll go to a house and ask you of my younger brother. Why? Because I saw both of you leaving. So the person I'm going to ask of this V2 is the person that is with V2, and that person is 650 millimeter mercury. That person is P2. So I'm asking P2 where is V2. And the V2 is 650, as we are seeing. The P2 is 650. So in essence, it is going to be 670 V2, 670 times 275 divided by 650. Divided by 650. 270 times 670 times 275 divided by 650. Let's make the calculation and get our answer. 670 times 275, okay, divided by 650. 275 divided by 650. So the answer is 283.461. The answer is 283.461. So if you calculate 670 times 275, it will give you 184,250. If you still calculate 650 times 283.462, it's still going to give 184,650. In essence, what we got here is the same thing as what we got here. So that means to say our answer we got is correct. Now, there is a graph of the Boyle's law. I showed it to you when I defined when the Boyle's law definition came on your screen, but I'll still give it to you. This is a graphical representation of Boyle's Law. Okay, that's the graphical representation of Boyle's Law. Here is the pressure, and here is the volume. So here is V, and here is P, and here is O. That is the calculation of Boyle's Law. And the graph is called isotherm. This graph, the graphical representation of Boyle's Law, this is called isotherm. So the graphical representation of Boyle's Law is called isotherm. The graph is called isotherm. As you can see, the pressure is reducing and the volume is increasing. So let's go to the next, which is the Charles Law. The Charles Law, Jacqueline Charles, okay? I told you he talked about as temperature increases and the volume will increase. Okay, this particular law, he brought it out in 1779, okay? 1779. It describes how the temperature increases and how volume increases. Definitely he used what they call it, oxygen as a gas, okay? When he heated oxygen, he saw that as the temperature is increasing, the volume is increasing. Why? Because the particles of oxygen are moving in most random motion. So as they are moving, they are increasing. As they are increasing, they are occupying more volume. Now let's know what the Charles Law tells us. The Charles Law states that the volume of a given mass of gas is directly proportional to its Kelvin temperature at constant pressure. To its Kelvin temperature at constant pressure. As long as the pressure is constant, the temperature must be constant. As long as the pressure is constant, the temperature must be constant. In essence, the volume too will be constant because the volume is equal to the temperature. So in essence, all of them are equal. Remember, it is the pressure that brings out temperature, and the temperature increases the volume. Okay, talks about the volume. So in essence, if the temperature reduces, the volume will reduce, and if the temperature increases, the volume will increase. Now, if the pressure is constant, the temperature will be constant, and the volume will be constant. Why? Because it says the volume is equal to the temperature. In essence, the temperature is equal to the pressure. Now, if you check on your screen, you see as the temperature is increasing, as the pressure is increasing, the temperature is increasing, and the volume is still increasing. So as it's reducing, everything is reducing. In essence, all of them are equal to each other, directly proportional to each other. Now, mathematically, it says V1, T1, V1 all over T1 is equal to V2 all over T2. In essence, the first volume will divide the first temperature. The second volume will divide the second temperature because all of them are equal. So the V1 is the first volume, T1 first temperature, V2 second volume, T2 second temperature. Now, you can see the graphical representation and the illustration. When you look at the illustration very well, you see that the pressure is that fire. Okay? As the pressure is increasing, the temperature is increasing. And the volume too is increasing. As you can see, volume too is increasing. So, let's take a quiz on Charles Law. Let's take a quiz on Charles Law. Remember, if they tell you in Boyle's Law, what is constant is the temperature. What is constant is the temperature in Boyle's Law. Now, what is constant in Charles Law is pressure. What is constant in Charles Law is pressure. So if they give you a question and they say at constant pressure, you know it's Boyle's Law. If they give you a question and say at constant temperature, you know it's if they give you a question at constant pressure, you know it's Charles Law. If they give you a question at constant temperature, you know it's Boyle's Law. If they give you a question that talks about volume and temperature alone, you know it's Charles Law. If you talk about pressure and volume alone, you know it's Boyle's Law. Now, This one is Charles' law. Let's take a question on Charles' law. Let's take a question on Charles' law. Charles' law says, a sample of oxygen gas occupies 220 centimeter cube at 270 degrees centigrade. What will be the volume at 150 degrees centigrade? Now, our first volume, following the solution, following the formula for Charles' law, V1 divided by T1 equals to V2 divided by T2. Now, our V1, you remember the first volume, like I said, is the V1, is 220 centimeter cube. Okay? Our temperature there, degree centigrade, is 27 degrees centigrade. Then our V2 is not given. They say what will be the volume? That means our V2. But our T2 is given at 150 degrees centigrade, our T2. So, how do we get our V2 following the formula? How do we get our V2 following the formula? Now, they said V1 divided by T1. Now, what is our V1? Our V1 is 220 centimeter. Our V1 is 220 centimeter cube. Divided by our T1, which is 27. They said it is equal to V2, that is unknown, divided by 150. This is it. Divided by 150. Now, how do we get V2? You do a cross multiplication. Okay? 150 will times 220 and 270 will times V2. That's the cross multiplication. You do a cross multiplication. Okay? Now, this cross multiplication is telling us that this 220, this is cross multiplication. This one will cross this one, and this one will times this one. So if this one times this one, it will give us 220 times 150. This one will times this one, divided by V2 times 27. Because 27 is down. So as you're dividing it, you're making a cross multiplication on that. So therefore, our V2 will be equals to 220 times 150 divided by 27. So our V2 will be 220 times 150 divided by 27. That will be our V2. So when you calculate this thing, you get your V2. So 220, okay? So therefore, V2 will be equal to 220 times 150 divided by 27. Let's get our answer and see. 220 divided by 150. 220 times 150, sorry. 220 times 150 divided by 27. So our V2 will be 1,222.2. Our V2 will be 1,222.2. That's our V2, centimeter cube. You must have to put the SI unit, otherwise your answer will be wrong. Okay, so in essence, our V2 is 1,222.2 centimeter cube. Now, if you carry this 1,222.2 and place in V2 and make your division, you will see that the answer you get here will still be the same answer that you get here. The answer you get will still be the same answer that you get here. Now, let's make the simple, what do you call it? Let's make the simple proof. Let's take a proof now. Let's take a proof so that you understand what I'm saying. Now, the Charles law states that P1, the Charles law states that V1 all over T1 is equal to V2 all over T2. Now, our V1, okay, is 220. Okay? And our T1 is 27. Then our V2, this is our answer, is 1,222.2 divided by our T2, which is 150, V1 all over T1 equals to V2 all over T2. Now, if you do 220, okay, if you do 220 divided by 27, it will give you 8.14. 8.148. Okay, it will give you 8.148 here. Now, if you still do 1,222.2, 1,222.2 divided by 150, it will still give you 8.148. In that sense, the one side is correct. Because anything you get here must be equal to what you get here. Otherwise, it's wrong. Because they say V1 all over T1 is equal to V2 all over T2. Equal to, that means they are supposed to be the same. So take note on that. If your answer here is not the same thing as here, then the answer you got is wrong. Okay? Now, the volume of a gas, okay, the volume of a gas depends on the temperature and pressure. The volume of a gas depends on the temperature and pressure. According to Boyle's law, he said when the temperature is reducing, the volume is increasing. Sorry, when the pressure is reducing, the volume is increasing, according to Boyle's law. And Charles' law states, when the temperature is increasing, the volume is what? Increasing. So the volume of a gas, take note, depends on the temperature and the pressure. The next one is Avogadro's law. Avogadro's law. Amadeo Avogadro brought out this law in 1882. In 1882, using a simple quantity of gas. Okay, it explains the quantity of gas at constant volume. The quantity of gas at constant volume. This law was brought in 1882. Now, what is the law? Okay, stating the law of Avogadro's law. It says, equal volume of all gases at the same temperature and pressure have the same number of molecules. In essence, if hydrogen and oxygen are equal, okay, if hydrogen and oxygen are equal and they are placed under the same temperature and pressure, they will have the same number of molecules. In essence, it's telling us that the movement of the molecules will be the same. The size of the molecules will be the same. The number of the molecules will be the same. The escaping tendency will be the same as you check. Okay, as you're seeing, the number of molecules are the same. So he said equal number of volume, equal volume of all gases. No matter the gas, as long as their volume are the same, the temperature will be the same, the pressure will be the same. In essence, it's telling us that the volume of gases is directly proportional to the number, to the temperature and pressure. Okay? Then the volume of gases is directly proportional to the temperature and pressure. That's what he said. You can define it like that. That the volume of gases is directly proportional to the temperature and the pressure. To each temperature and pressure. So mathematically, you say Vn equals to K. V is the volume, N is the number of moles, and K is the constant. V is the volume, N is the number of moles, and K is the constant. Take note. Now, let's take a question from there. Okay, now, the volume that these gases occupy is called molar volume. The volume that these molecules occupy is called molar volume. Remember, the molecules occupy spaces in the gas. The molecules occupy spaces in the gas at room temperature. Room temperature simply means standard temperature and pressure. Room temperature simply means standard temperature and pressure. When the temperature and pressure is standard, it becomes room temperature. So, the volume they occupy in these gases by 1 mole of any gas is called molar volume. Now, let's take a question. The quiz says, how many atoms are there in 4 grams of carbon? How many atoms are there in 4 grams of carbon? Very simple. This is the simplest. Okay? Now, how many grams are there in 4 atoms of carbon? Now, 12, and they gave you that C is equal to 12. In essence, carbon is 12 grams. Remember when we talked about the mega formula, changing molar formulas and molar, then when we talk about chemical formulae and equation. When we change grams, okay, when we change these things to grams, in moles, we change them to grams. You know that. I talked about that. So now the carbon is 12. Its molar mass is 12. In essence, it has 12 grams as 1 mole. How many atoms are there in 4 grams of carbon? Remember, the Avogadro's number is a mole. The Avogadro's number is a mole. You know that. So in essence, 12 grams of carbon is equals to 6.02 times 1023. And this is 1 mole. This is 1 mole. And that's when you're solving Avogadro's number, you have to, as Avogadro's number, you have to solve those things in mole. You have to solve those things in moles. So in essence, this 12 grams of carbon is 1 mole. If they give you a question, okay, the molar mass becomes a mole. The molar mass becomes a mole. So therefore, 4 grams of carbon will be equal to 4 over 12. Because they said how many grams is in atoms is in 4 grams of carbon. So 4 over 12 times 1 mole. And it will give me 4 over 12 times 6.02 times 1023. Simple. So if you do your division in this, okay, when you divide this thing, it's going to give you 2.02 times 1023. How many grams, how many atoms are there? So these are the number of atoms that is there. If you do a calculation like this, it's going to give you 2.02 times 10 to the power negative, times 10 to the power 23. Because if I carry 12, now let's make the division so that you don't get confused. Okay? It will be equal to 4 times 6.02 times 1023 divided by 12. So when you cancel, 12 cancel, 4 cancel 12, it will be 3. Okay? 4 cancel 12, it will be 3. I'm just doing a cancellation because in this solving, we do not cancel. We don't cancel when we are solving. I'm only trying to cancel it so that you follow up what I'm saying. 4 here is 1. 3 here will be 1. 3 here will be 2. So 1 times 2 is 2. So the remaining 2.02 times 1023. That is the answer. We do not cancel when we are solving. But I have to cancel so that you follow up what I'm saying. But in case you're writing an exam, you do your cancellation in a rough book and place your answer in your answer sheet. Okay, now, I want to give you, we have finished the quiz on Avogadro's law, but I want to tell you a simple, secret, okay? Now, there are 2 ways of solving Charles' law. Okay, the Charles law, in the temperature, when you're solving Charles' law in the temperature, you add 273 Kelvin to the temperature. You add 273 Kelvin to the temperature. Every temperature you see, you add 273 Kelvin. Why? Because the constant temperature is 273 Kelvin. 273 Kelvin gives you 1 degree Celsius or centigrade. 273 Kelvin gives you 1 degree centigrade or Celsius. So in essence, you convert the degrees, the Celsius to Kelvin before you start solving. And you converting it means you add 273 degrees Celsius, Kelvin. Take, for example, 3 degrees centigrade. I want to change it to Kelvin. It's 3 degrees centigrade plus 273 Kelvin. It will give me 276 Kelvin. It is not degree Kelvin, it's just Kelvin. You don't add degrees in Kelvin. This is conversion from degree centigrade to Kelvin. Now, conversion from Kelvin to degree centigrade. If I want to convert 273 Kelvin to centigrade, if I want to make a conversion from Kelvin to centigrade, I'll have to minus. I have to what? Minus. In essence, I will minus 273 degrees from 3. Okay, I want to change. I'll minus 273 minus 3. This will give me 270 degrees centigrade. 270 degrees centigrade. In essence, I'm converting from Kelvin to centigrade. I'll make a minus. Then converting from centigrade to Kelvin, I'll add 273. I'll add 273. Then if I want to convert from Kelvin to centigrade, this is degree centigrade to Kelvin. If I want to convert from Kelvin to centigrade, I will minus. Now take for example, I want to convert 3 Kelvin to centigrade. I will have to say 3 minus 273. It will give me minus 270 Kelvin. I've converted from Kelvin to centigrade. So that is a way to solve Charles' law, or that is the way of conversion of this process. Now we've come to the end of this particular lecture, but before we leave, let's take questions from our exam guide to quantify what we have learned. Okay? Now this is 2009 number 21. They say, what is the value of minus 14 degrees centigrade on the Kelvin temperature scale? On the Kelvin temperature scale. I told you, if you want to convert from centigrade to Kelvin, you must have to add 273 Kelvin. 273 Kelvin, that is the standard temperature. Okay, just a simple thing. If we say minus 14 plus 273, it will give us 259. Simple. So the answer is 259 Kelvin. Minus 14 plus 273 will give us 259 Kelvin. So the answer is 259 Kelvin. The first one they say Kelvin, the second one they said 259 degree Kelvin. I said in Kelvin, you do not put degrees. Okay, Kelvin is Kelvin. So the answer is A, 259 Kelvin. Now the second one, our second question tells us 2009, okay, 2011 question 13. 2011 question 13. Question 13. Question 23. 2011 question 23. It says the equation P equals to K over V illustrates. The equation P equals to K over V illustrates. I told you that Boyles, I told you about the laws. Okay? If you check there, there's no temperature. You have only pressure and volume, and the K is the constant. And I told you that PV is equal to K. And looking for P will be K divided by V. Where P is the pressure, K is the constant, and V is the volume. In essence, that thing I told you, we know that is a Boyle's law. P1, V1 equals to P2, V2. Then, or you can say P equals to, PV is equal to K. Now, looking for P will be K divided by V. So the answer is A, the Boyle's law. Now, the last one is our theory. Let's go to the theory part. I want to make out something, explain something to you in that theory part. So this is the third question we are going to take. And the third one states that if 250 centimeter cube of a gas at standard temperature and pressure is heated to 27 degrees centigrade at constant pressure, calculate the new volume. In essence, standard temperature and pressure, like I told you, is the room temperature. Now, if you check, they said at constant pressure. Constant pressure. I told you that when the pressure is constant, it's Charles' law. When the temperature is constant, it's Boyle's law. So take note on the questions. When you see a constant pressure, it's Charles' law. When you see a constant pressure, is a temperature, it's Boyle's law. I know why I took this particular one, because in this one, it's going to be confusing to you if you do not understand how to solve it. Now, this thing now is Charles' law, because the pressure is constant. Now, Charles' law, okay, is V1 all over T1 equal V2 all over T2. Okay, now, they said our first volume is 250. So the V1 is 250 centimeter cube. While the T1 is 27 degrees centigrade. I told you the first volume is the V1. Second volume is V2. First temperature, the first temperature on the question is T1, and the second temperature is T2. Now, if you check, there is no V2, and there is no T2. How do you solve this one? The temperature, a constant temperature, like I told you, is 273 Kelvin, and it's always on the second temperature. The constant temperature is always affiliated with the second temperature. 273 Kelvin is the constant temperature, and is affiliated with the second temperature. So if they give you a question and there's no second temperature, the second temperature is the constant. Second temperature is the constant, because as the pressure increases, the temperature increases. That temperature increases is the second temperature. So the second temperature becomes the constant, which is 273. So therefore, our second temperature, therefore, our T2 will be 273 Kelvin. That will be our T2. Like I told you, why? Because the second temperature is always a constant. So if they give you a question and there's no second temperature, 273 becomes the second temperature. So now you can solve now. Now, solving will be V1. The V1 is 250. All over 27 equal to V2 all over 273. You see why I said I want to take this question? Now you do a cross multiplication, like I said. Cross multiplication. It will be 250, so therefore is equal to 250 times 273 divided by V2 times 27. Now, V2 therefore will be equal to the same thing we did, 250 times 273 divided by 27. So therefore, our V2 will be equal to what? What will be the new volume? It will be 250 times 273 divided by 27. So our answer will be 2,527 to go to 2,527.8. That will be our answer. Centimeter, don't forget, centimeter cube. Centimeter cube. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.